In this video, we're going to be looking at Riemann sums, left hand, right hand, upper, lower, and midpoint sums. And you need to understand that in calculus, there's only two major sections, or two major goals. One is to find the slope of a curve, and the second part is to find the area underneath the curve. But back in the old days, they did not know the exact area underneath the curve. They did not know how to figure it out. So Riemann found a way to estimate the area underneath the curve. So Riemann sums are really estimates of the areas underneath the curve. All right, so let's go ahead and look at it. What's the objective? To distinguish between right hand, left hand, and midpoint sums, sketch the rectangles in Riemann sums, distinguish between upper sums and lower sums, set up the area of the right hand, left hand, midpoint, upper, and lower sums, determine if a shortcut is applicable in any of these sums. Okay, so this is the goal of calculus. You want to find me the area from a equals 0 to b equals 3 here, and you want to find this area, but we don't know how. So Riemann, what he did was he says, you know what, I can use rectangles. All right, so he decided, well, I'm going to use rectangles here, and all my base here is going to be 1, that's going to be 1, that's going to be 1. I find the heights, that's going to be the height of my first rectangle, which is determined by my function. And here's my second height, which is determined by my function. And here's my third height, which is determined by my function. Now, if you look at this one rectangles here, they all have something in common. Here's my interval here, and I chose the left side to go up to hit my function. Here's my base, and I use the left side to hit my function. So this is what we would call the left-hand sums. Okay, because somebody went out and said, wait, let's look at it. Let's look at this one. It says, wait a minute, Riemann, that's horrible. That's a horrible estimate, because if you look at it, look at all the area you're missing. You're missing this piece. You're missing this piece. And look at this one. This is a humongous piece that you're leaving out. And he says, yeah, I know that. I understand that. But what happens if I draw more rectangles? All right. So he just said, let's add more rectangles to my from 0 to 3 part. So I got from 0 to 3. He added 1, 2, 3, 4, 5, 6. He added 6 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. He added 10 there, and he added a lot there, and he added way more there. So what happens when you add more rectangles? Well, when you add more rectangles, you're going to get a better approximation. Now, as the number of rectangles goes to infinity, then you're going to have the exact area underneath the curve. Okay? All right. So now, how do you find the area of a rectangle? The area of a rectangle is going to be base times height. So in this case, I have two rectangles, and I'm going to go from 0 to 3. So I'm going to go 3 minus 0, and I'm going to divide it by the number of rectangles, which is 2. So 3 halves, this length here is going to be 1.5, and this length is going to be 1.5. So if you notice my area here, this is 1.5 and this is 1.5, which are my bases. Now, the heights are going to be determined by whichever side you pick. So in this case, we're going to pick the left side. So right here, who's on the left? Well, 0 is there, and this is 1.5 here. So I'm going to pick the one on the left. So it's going to be f of 0, which is the y at 0, and then the other one's going to be the y at 1.5 to find the heights. Multiply that out. Figure out the y's first. Multiply them out, add them, and that gives you the estimate of the area underneath the curve. Okay. Now, somebody decided, wait, I'm going to draw the rectangles on the right side. So instead of going from 0 to 1.5, well, it's still going to be from 0 to 1.5 here. This is 1.5. This is 1.5. So my bases, if you notice, my base is 1.5 and 1.5. But now the heights are being determined by the right side. So on the right side, I'm going to go up, hit my rectangle, and then go to the left side. And this is my first rectangle. In this scenario, I'm going to go to the right side, which is the 3. I'm going to go straight up until I hit my graph, right? And then I go to the left, and I go down. And this right here is going to be f of 3 times 3 halves. So then this is the height at 1.5, and this is the height at 3. Multiply that out, and that's going to give you, and this is what we call the right-hand sums, because my rectangles are determined by the right side of the intervals. Okay? Now, somebody out there might say, well, wait. I'm gonna go in the middle from 0 to 1.5. So from here to here is 1.5. I'm gonna go to the middle, go up, and I hit it. I go from what is this, 1.5 to 3, and I'm gonna hit it. So my heights, oops, I made a mistake here. Okay, so my heights, well, not really. I'm still gonna have 1.5. I'm gonna have 1.5. Now my heights here is gonna be the middle of 1.5. So I'm gonna take 1.5, which is 3 halves, and I'm gonna take the half of that. So the half of 3 halves is gonna give me 3/4. So I want the height. This guy right here, he's 3/4. So I want the height here. So that's called f of 3/4. The next height is going to be in this scenario, right? So how do you find that middle guy? Well, you can go 3 minus 1.5, right? Oops, I'm sorry. 3 plus 1.5 divided by 2. So you add them up, divided, because you're trying to find the average of those two. So if you figure this out, you're going to say 6 halves plus 3 halves over 2, and that's going to give me 9 halves over 2, which is really 9/4. Okay? And this is what we call the midpoint sums, because I'm using the middle of each interval to find the heights. Okay? Alright. I already discussed this. This is, if you notice, they all have the same base. But here, the left side is the one that determines my heights. Here, the right side of each interval is the one that determines my height. And here, the middle is the one that determines my height. So this is what we call the midpoint sums. This is the right-hand sums, and this is what we call the left-hand sums. Now, you need to understand the ideology between overestimate and underestimate. An overestimate means that the rectangles, the sum of the rectangles, is going to be greater than the exact area underneath the curve. Okay? So if you look at this picture here, do you notice that my rectangles here, they're all above my function? So therefore, this one's going to be called an overestimate. Okay? Now here in this one, all my rectangles are below the function, so that if I add up this, it's not going to give me the exact area underneath the curve. It's actually going to give me an underestimate. Now sometimes you're gonna do the midpoint sum. Sir, is that an overestimate and an underestimate? And honestly, you really can't tell. So this is going to be a big fat question mark, because we don't know. Is this bigger than this? Is that bigger than that? Is that bigger than that? But then you have to add them up. So that's sometimes very hard to determine on the midpoint sums here. Okay. So in this one is, can you estimate whether the left hand or the right hand in the mid are they going to be an underestimate, an overestimate? So all I have to do is, instead of trying to do 50 rectangles, just do one big fat rectangle here, right here. So if I use the right side, this guy right here, he's a right hand estimate, and the right hand estimate is going to be an underestimate. Okay. Now if I do the left hand sum, if you look at the left hand sum, I use the left side until it hits the function. This is a left hand sum, and that one's going to be an overestimate. Okay. Now let's do it over here. If I do the left, what are you noticing about the left? It's still considered to be a what? The left hand sums is going to equal an overestimate. Okay, and if I do the right hand sums again, the right hand sums is going to be 0. That's a horrible estimate. With one rectangle, it's going to be an underestimate. Okay. Alrighty. So let's look at the exact same function, and we're going to be looking at the exact area underneath the curve. This is what we want. Okay, we want to find the exact area underneath the curve here, right? So if I look at the left hand, I use the left hand. I broke it up into 3 three rectangles. Each one has three rectangles, right? This is a left hand, this is a right hand, this is the midpoint, and this is the exact. So this is just a visual so you can see the three sums and the exact. Okay. All right. I found the exact. I found the work. Here's the work. You can pause the video and you can look at the work for finding each area for those estimates. Okay. I'm just setting them up. Now, we're going to do an example together here. We're going to find set up the Riemann sums that approximates the areas from 0 to 1 using 4 rectangles. Ooh. All right, so I got 0 here, and I'm going to go all the way to 4, and that means that's 1, 2, and 3. Oh, I picked an easy one. Ooh. Every base here is going to be 1. Every single one of them is going to be 1, so that's going to be easy, right? So let's go ahead and do the right-hand sums. The right-hand sums, that means that I'm going to pick the right side between 0 and 1. So I'm going to say 1 times f. Oops, let me undo that parentheses here. 1 times f of 1 plus 1 times f of 2 plus 1 times f of 3 plus 1 times f of 4. That's it. That's the way you set it up. Okay. What about the left-hand sums? The left-hand sums, the bases, all the bases are 1, I said. Okay. So now instead of, here's my first interval. Don't pick the 1. You're going to pick the left side of this interval. Okay. Who's on the left side? This guy's on the left side. So 1 times f of 0 plus 1 times f of 1 plus 1 times f of 2 plus 1 times f of 3. That's it. Now, what about the right-hand sums? The right-hand sums, the bases, all the bases are still going to be 1. But now the heights, I'm going to pick the ones in the middle. So it's going to be f of 0.5. And then the next one's going to be 1.5. The next height is going to be determined at 2.5. And the last height is going to be found at 3.5. Okay. And then what do you do to find the heights? You insert them into this function to find the heights. Okay. But we were just setting up. Okay. Let's try another one. Okay. Let's go ahead and we're going to go from 2 to 5. So I'm going to go here to 5. 2 to 5. All right. You got 2. And you're trying to, let's go with 3 and 4. So this guy is 3 and this guy is 4, and it says use 3 rectangles. Oh, I did it again. All right, I chose a perfect number. So the right-hand sums is going to be, each base is going to be 1 times f of 3 plus 1 times f of 4 plus 1 times f of 5. The left-hand sums, we're going to use the left sides, which means I'm going to use the 2, the 3, and the 4. So we're going to be 1 times f of 2 plus 1 times f of 3 plus 1 times f of 4. The midpoint sums are going to be determined by the guy in the middle. So the guys in the middle here is going to be that guy, and that guy. It's going to be 1 times f of 2.5 plus 1 times f of 3.5 plus 1 times f of 4.5. Alright, let's continue. Well, what I did here is I gave you the tables, and the tables, they're going to ask you to set up some Riemann sums. We're going to have the left-hand sums, the right-hand sums, the midpoint sums of this table. And they're going to ask you to go from, I don't know, from 0 to 30, and they're going to tell you how many rectangles. And in this case, they're saying 3 rectangles. So here's where I lose some students. They don't understand that you have to start at the 0 and end at the 30, but you got to go in terms of 3 jumps. So you're going to go from 0 to 10 is 1 jump. From 10 to 20 is another jump. From 20 to 30 is going to be another jump. That's how they get the 10s. Okay? That's how they get the 10s for the bases. Now, if I had said 1 rectangle, then it would be 0 and 30, then my base would be 30. If I had said 2 rectangles, it would be from 0 to 15, and then from 15 to 30. So every base would be 15 if I had asked for 2 rectangles. What if I had asked for 1, 2, 3, 4, 5, 6? If I had asked for 6 rectangles, then every base would be 5. And then for the left-hand sums, who's on the left side, 0 or 5? 0, so I pick the 1. Then the 1, then the next, who's on the left side, 10 or 20 or 15, I will pick 10. So then on the 10, I will pick 1.7. Who's on the left side, 20, 25, or 30? 20 would be on the left side, so I pick the height there of 1.8. For the right hand, I choose the right side, which would be 1.7, 1.8, and 1.4. And for the midpoint sums, we choose the one in the middle, 1.2, 2.0, and 1.6. It's a lot easier to look at it when it's lying down like this, a table. Here they want to go 4 rectangles. You're going to start from 0 to 8 and they want 4 rectangles. So I'm just going to make a jump here, a jump here, a jump here, and a jump here. That's 4 jumps. That means that this base will be 2, 2, 2, and 2. All my bases are 2. So if you notice, they all have 2 for my bases. And then the heights are determined by whichever sums you're looking for. So on the left hand, I'm looking for 0. So I'm going to pick 32. On the next interval, I want to pick 11. On the next interval, I'm going to pick 4 and then -4. On the right hand sums, I'm going to pick 11, 4, -4, and 3. So I made a mistake here. I put an 8 here, and it should be a 3. Okay. So then the midpoint sums, on the midpoint sums, that's an easy one because we just choose the one in the middle. So I'm going to pick 9, 7, 6, and 8. 19, 7, 6, and 8. Okay. So let's try another one. Okay. What if I ask you to do 1 rectangle? Well, the 1 rectangle, you're going to go from 0 to 30. So let's do the right hand sums. We have the left hand sums, and we have the midpoint sums. So the base is going to be very simple. 30 is going to be my base, and the height is going to be determined by what? By whichever one I want. So right hand, 30 will be the right hand, so I'm going to pick 1.4. I'm done. I'll multiply those out and I'm done. For the left hand sums, I'm going to pick this guy, which is going to go with 1, so I'm going to multiply it times 1. So that's going to give me 30. Okay. Should I multiply this out? Yeah. So that's 1242. Okay. So the last one, they want the one in the middle. So who's the one in the middle? Is 15 the one in the middle? Yes. So I'm going to pick 2. That's going to give me 60. Okay. And that's it. That's how you approximate the right hand, left hand, and midpoint sums. Here's another one. Okay. Now they want 2 rectangles. You're going to start at 0, but you got to end at 8. So you're going to go from here to here. That's 1 jump, and from here to here is another jump. So every base here is going to be that's a 4, and that'll be a 4. So my right hand sums is going to equal to 4 times the one on the right side, which is going to be the 4. It's going to be 4 plus on the right side is 8, so it's going to be 4 times 3. The left hand sums is going to be 4 times 32 plus 4 times 4, because I have to choose this one. For the midpoint sums, I'm going to choose the one in the middle, which is that guy. Alright, so it's going to be 4 times 11 plus 4 times -4, which is that guy. Okay. Now for the lower sums, here's the only thing that you have to understand for lower sums and upper sums. The lower sums and upper sums, you have to find the lowest spot in that interval for the lower sums, and you have to find the highest spot in that little interval in order to find the upper sums. Okay, so I want you to notice in this picture here. In this picture, this guy, this one here, he's a left hand. This guy's a left hand. This guy's a right hand. And this guy is a right hand. In this scenario, this guy is a right hand. Oops, this guy's a right hand, this guy's a left hand, and this guy's a left hand. So it can be a combination of left and right hands, or sometimes it might be a midpoint sums in there too. Okay, but when I give you the table, it's a lot easier to do the upper sums and lower sums. All right. So they want one rectangle, so I'm going to go from 0 to 30. So I'm going to do the lower sums. So my base is going to be 30, now, and then all you have to do now is find the lowest y value here. Which one is the lowest there? The lowest there is 1, so my lower sums is going to be at 30. The upper sums is going to be the highest though. Okay, so what is the highest value there? 2. So my upper sums is going to be 60, and I'm done. Let's try another one. So let's do the lower sums. They want 2 rectangles, so I'm going to go, remember, start at 0, go to 4, and then 4 to 8. So my bases are going to be 4. Okay, my bases will be 4, and then for my, oops, not right hand, it's supposed to be upper sums. For my upper sums, still my bases are still 4. And now, ready? For my lower sums, I have to pick the lowest in this interval. What's my lowest in that interval? The lowest in that interval is going to be a 4. And on my next interval, what's my lowest in that interval? Well, it's going to be -4. For the upper sums, you're going to find the highest. Which one is the highest in that interval? Well, the highest is 32. And the highest in this interval will be 8. And that's it. That's how you set them up. Okay? And that concludes the video.